video, I will explain the initial connection of IoT ESP32 and the single point U, and will conduct three exercises. The video is divided into 5 parts. The part 1 is main connector. Part 2 is matrix list. Part 3 is called analysis. Part 4 is single point EU connection. And the part 5 is final effect demonstration. Okay, this is the part 1, main connector. The main connector is to connect ESP32 and single point U. And conduct 3 exercises. The exercise 1 is to control the light switch. Exercise 2 is make the light flash at a frequency of 2 seconds. And the exercise 3 is to make the light flash at a faster frequency. And the final effect video will be placed at the end of the PPT. Next is the second part. The matrix used first is the hardware requirements is ESP32, and the 2 is the onboard LED. The software requirements is Arduino IDE and the single point U. Okay. This is the part 3, exercise 1 code analysis. This is the code. Exercise 1. It connects the ESP32 to a mobile phone hotspot there. And finally connects to the single point U. An LED panel will appear on single point U, collecting the button will toggle the blue light on the ESP32. I will analyze this step by step. Okay, this is the 1 point. Other flows the micro definitions. Import the single ESP32 library and define the code implement form, create missions and Wi-Fi information. Okay, this is the part 2. Create a scene object. Associate it with the username, device ID and key. This is the part 3. Set up function. Initialize several connections and set GPIO2 as output and connect to Wi-Fi. This is part 4, called resource loading. Map GPIO2 to single point use light virtual switch. This is part 4, a loop function. Maintains code communication and process remote contents. Each code segment functions independently but communicated but combined. They enable root LED control. This is the exercise 2. This is the code for exercise 2. The provide steps the same as exercise 1. Connect the ESP32 to the mobile phone hotspot and finally connect to the single point U. And the LED blink deadly section will appear on single point U. Click the blue button and the blue light on the ESP32 will flash gradually. This is the point one header from the micro definitions. As in exercise 1, input the single ESP32 library and define the username, device ID key, and the Wi-Fi SSID and the password require for the device to connect to single point EU. This is the part 2. Global variables and object initiation. Create a single ESP32 object scene and declare the LED blink variable to control the LED blinking pattern. This is the pass-through setup function. Initialize the serial connection. Set GPIO2 onboard LED to output model. Connect to Wi-Fi and blind the code control interface. This is the part 4 loop function. Continues to handle cloud communications and controls the LED blocking. 2 seconds on and 2 seconds off, besides on the LED blink state. This is the code for exercise 3. The concepts are same as exercise 1 and exercise 2. Connect the ESP32 to the model phone host port and finally connect to single point EU. The LED blink deadly fast. Section will appear in single point EU. Click the blue button, and the blue light on the ESP32 will flash gradually at the frequency of 0.5 seconds, which is faster than the flash frequency in exercise 2. This is the point 1 hardware flash and macro definitions. As the exercise 1 and 2, import the single ESP32 library and define the authentication information and Wi-Fi connection information required for the device to connect to the single point EU platform. This is the point 2 global variables and the object initialization. Create a single ESP32 instance and declare the LED control flag variable. This is the point 3 setup function. In Telnet serial connection, set up GPIO2 to output model, connect to Wi-Fi, and blind the cloud control interface. This is the part 4 loop function. Handles cloud communication and controls LED flashing according to different modes. This is the part 4. This is the single point EU. Interface after completing the 3 exercises. 3 switch will appear. Exercise 1 uses the LED. This model to turn the light on and off. Exercise 2 is used the LED blink deadly model to make the light blink. The exercise 3 use the LED blink deadly fast model to make the light blink at a faster rate. This is the final effect. This video shows the final result. This is the code for exercise. Okay. This is the code for exercise 1. This is a single point connection page for exercise 1. Link the button to turn it and off. The blue light will line on the ESP side will turn on and off accordingly. This is the code for exercise 2. This is the single point L connection page for exercise 2. Click the button to turn it on and off. That the blue light on the ESP32 will start blinking at a rate of 2 seconds. Okay, and then this is the code for exercise 3. And this is the single point EO connect page for exercise 3. Click the button to turn it on and off, and the blue light on the ESP32 will start blinking at a faster rate of 0.5 seconds. And this is show the 3 exercises. This is single point EO. Okay. My explanation is over. Thank you for everyone.